Works? I don't know.
It's only for the recording. So.
Ah, okay. All right. Okay. So I hope I have. Judah was born in Cincinnati, United States, and grew up in a family that was deeply rooted in Jewish tradition. His father being a scholar and leader in Jewish education. And in fact, when he eventually emigrated to Israel, he was fluent in Hebrew, started to teach right away in Hebrew. Not just fluent, so fluent that if we had a problem with Hebrew words, we would go to him to get answers. He got his PhD at the age of 24 at MIT, and then went to the University of Virginia, where he stayed for 13 years and became professor and department chairman. Wrote a very well-known book in the theory of nuclear physics, and was recognized as one of the leading theorists in this field. And obviously, when in 1975 he decided to emigrate to Israel and to come to Tel Aviv University, we were so delighted and were so happy that he joined us. At that time, the hot topic in nuclear physics was the study of interaction between pi mesons and nuclei. Pi meson exchange is considered the way nucleons in the nucleus exchange the force, the interaction between them. So interaction of pions with nuclei was considered one of the interesting things to do. And 3 meson factories, so-called 3 accelerators, were built for this purpose in Switzerland, the United States, and Canada. And Judah was definitely one of the gurus of this field. And we as experimentalists worked on all 3 of these accelerators. We developed experimental program, and he was our daily mentor and all the time giving us good advices. And the interaction and the collaboration was so good that, just to give an example, our colleague Eli Piasecki did his master thesis with Judah in theoretical physics. Then he came to me and worked with me in experimental physics in the same field. And at the same time, Judah had another theoretical student that worked on the theory of his experiment. So it was all combined, and it was a wonderful collaboration. And I must say, not only in physics, because whenever we would come to him for the question in anything, we knew we would get an answer. Whether he knew it or he would find out, and without Google, he was able to give us complete answer to our questions. We enjoyed particularly the work with him in a place, a singular place in the world, in Vancouver, Canada, where one of these 3 accelerators were located. And in the summers, we would go there to do experiments. He would be there, Avram Gal would be there, people from Weizmann Institute would be there. It was a very active and very intense collaborative statement. And Judah, on top of being our physics leaders, he was the leaders in hiking on the mountains, because he knew basically every trail in the mountains around Vancouver. It was very sad that this career stopped so early. He was still a dean of this faculty. He was vice rector of this university, and then at the age of 60 he died.
Thank you, Danny. And now I would like to invite the chairman of the School of Physics, Professor Andelman, and Judah's daughter, Debbie, to award our yearly fellowship to outstanding graduate student. Please.
So it's one of the pleasure of my duties is every year we choose one of our best students and we award this fellowship for excellence in research. Eli is supervised by Professor Eran Rabbani from the School of Chemistry, from Physical Chemistry. And I'm not sure whether would you like to say a few words of, you bring the big boss to say a few words. Okay, so Professor Rabbani will say a few words. Maybe we take a picture before that. Where is it? Okay, so would you like to, okay, so.
You get it.
Okay, so congratulations and all the best. Eran, would you like to say a few words?
Just a couple of words. I want to say I'm proud for two reasons today. The first one is that I can take physics students to my lab, and it's not an obvious thing for me. And as a matter of fact, getting access to excellent students, I consider this now as a lifesaver. I don't have any more chemistry students in my lab, only physics students. And the other thing that makes me proud is that one of my students is getting, I'd say, the most prestigious award from the School of Physics for graduate students. And this makes me very proud as well. Eli's research, in a couple of words, is on many-body quantum physics away from equilibrium. And Eli has made a very significant, I think, discovery about having more than a single steady-state solution of the problem, even on time scales that exceed any time scale that we can actually compute in systems with electron-photon interactions, and his predictions are still waiting for experimental verification. So Eli's the kind of theorist that likes to make predictions, and hopefully in the future these would be sorted experimentally. So again, thank you very much for choosing Eli, and I wish you luck.
This is Debbie.
I'm Debbie Shalev. I'm Judah Eisenberg's eldest daughter. And it's always a pleasure for me to come to Tel Aviv University. I grew up here, both professionally. I'm a chemist by profession. And personally, I learned to ride a bike here. I went to camp here. And so being Judah's daughter, I, of course, developed an affinity to the Tel Aviv University, but also to science. And one of the things that I know is that my father's love of science was something that was evident to his colleagues, to his students, certainly to his family. And he used to do little experiments for us and little quizzes over dinner. So we grew up with the same love of science and many other things, as Donnie said. So another thing that I wanted to say is that I'd like to thank Professor Gabriels for coming and giving us the honor of lecturing here today. And to Eli, congratulations. And of course, it's wonderful for me to see that chemists and physicists get together not just in families, but also in real life. So thank you. And good luck.
So we are very proud and happy to have as our colloquium speaker today Professor Gerald Gabrielze from Harvard. Professor Gabrielze received his PhD from University of Chicago in 1980. He was a postdoc and then faculty member in University of Washington in Seattle, and then very quickly, I think in his early 30s, he was snatched by Harvard and became a professor at Harvard. And I think he can best be described as a magician, experimental magician, who keeps pulling incredible rabbits out of his hat every couple of years. He does things that most of his peers and community believe to be impossible. And for this, he was elected in 2007 into the National Academy of Sciences. And just to mention some of his crucial contributions, he was the pioneer in storing antiprotons, and which paved the way for doing anti-atoms and anti-hydrogen. And some of you may be familiar with the subject from the movie that was done recently, the movie Angels and Demons, which introduced the general public to the antimatter research at CERN. He constructed traps in his lab which made it possible to test the fundamental CPT theorem to unprecedented precision, equality of masses of protons and antiprotons, anti-atoms. He measured the magnetic moment of an electron to unprecedented precision of 1 part in 10 to the 13th. Quite recently, he measured the electric dipole moment of an electron with a precision 10 times better than anybody else before. And this, luckily, puts very strong constraints on theorists who cannot go wild and have to live with these experimental facts. And there is a good chance that if there is physics beyond the standard model, Professor Gabrielse will be one of the first people who will get a glimpse at that physics through his high precision experiments. So please.